This video is going to cover section 12.1 on linear equations. So by the end of this chapter, so we're jumping to chapter 12, and by the end of this chapter, you should be able to discuss basic ideas of linear regression and correlation, create and interpret a line of best fit, calculate and interpret the correlation coefficient, calculate and interpret outliers. So we often want to know how two or more numeric values are related. So is there a relationship between a grade on the second math exam a student takes and a grade on the final exam? If there is a relationship, what is the relationship and how strong is it? Another question might be, or an idea that your income might be determined by your education, your profession, your years of experience, your ability. So like your income is one variable, and then education or profession or experience or ability could be the second variable. The amount you pay a repair person for labor is often determined by an initial amount plus an hourly fee. And this type of data that we're talking about is bivariate data, bi for two variables. There is also multivariate data, meaning many variables, but those relationships are a lot more complicated, and we're just going to focus on bivariate data here. So linear regression. So linear regression for two variables is based on a linear equation with one independent variable. And the equation has the form y equals a plus bx, where a and b are constant numbers. So this probably looks familiar to you, but the a and the b are different than what you might have seen in algebra classes. Usually we have something like y equals mx plus b. And so when we're talking about in statistics about linear regression, we use different variables, which are going to mean the same things, but just have different names for them. So x is the independent variable and y is the dependent variable. And here are two examples of linear equations. So y equals 3 plus 2x, or y equals negative 0.01 plus 1.2x. The graph of a linear equation in the form y equals a plus bx is a straight line. And any line that isn't vertical can be described by this equation. So a is where the line crosses the y-axis and is the value our equation takes on when x is 0. This is our initial value, or sometimes we consider it like our fixed cost. B is our slope, and it's how much y changes when x goes up by 1. It's our rate, the rate that things change. So again, if you think back to algebra classes, B used to be our y-intercept, but now A is. M used to be our slope, and now B is. And our slope is our rate of change. And remember, it's rise over run, how much you go up by how much you go over. And it can be considered like how much you change, your y changes when x goes up by 1. So just a few graphs of nonlinear equations just to have them in your mind. Here's a picture of a quadratic. This is y equals x squared. This is an exponential, y equals bx, where b is some number. This is what a quartic looks like, and that is y equals x to the fourth power. Here's a cube root function. I wrote it as with a rational exponent instead of writing it as the cube root. And then this is a reciprocal function, which is 1 over x. So you can have data that might fall into one of these kind of categories, but we're just going to be looking at linear data in this class. So a couple of examples when we're going to be writing a lot of linear equations. So this is example 12.3. So Aaron's word processing service does word processing. The rate for the services is $32 per hour plus a $31.50 one-time charge. The total cost to a customer depends on the number of hours it takes to complete the job. So we're going to find the equation that expresses the total cost in terms of the number of hours required to complete a job. So make sure when you're reading these problems, you read them carefully, because sometimes they give you clues to how you're going to write your equation. So total cost will be on one side, and then that'll be our y value. And then in terms of the number of hours means that's going to be our x variable. So, like I just did, define our variables and be specific. What is the independent variable? What is the dependent variable? So independent sometimes means it's the one that changes first, and the dependent variable, the value of that is going to depend on what the independent variable is. So our total cost is going to depend on how many hours required to complete the job. So Y is going to be total cost, and X is going to be the number of hours taken to complete the job. We'll see that in a second. So the next step you want to do is you want to determine if there's anything that is fixed and doesn't change. And in this example, it says that there's a one-time charge. And then we write our equation with those pieces of information. So again, X is the total number of hours the job takes. So that's independent. And then the total cost of the job is going to be Y, because that's going to depend on the value that X takes on. The $31.50 is a one-time charge, so that's what's fixed or doesn't change no matter how many hours are worked. So our equation is going to look like Y equals $31.50 plus 32 times X. So another example, Emma's Extreme Sports hires hang gliding instructors and pays them a fee of $50 per class, as well as $20 per student in the class. The total cost Emma pays depends on the number of students in the class. Okay, so this tells us something, that we're going to write the equation that expresses the total cost to Emma in terms of the number of students in a class. So we're going to define our variables, what's independent and dependent. We're going to determine if there's anything that is fixed, and we're going to write the equation. So X is the number of students in the class. That's independent. Y is the total cost of the class, and that depends on how many students are in there. The $50 is fixed because the instructor gets $50 per class, no matter how many students there are. And so that allows us to write the equation Y equals 50 plus 20 times X. So the rate, the thing that goes up, or the thing that we're going to multiply by our independent variable is the rate, which is the 20 per student. And then the 50 is the fixed. So that's why it's not being multiplied by X. So for the linear equation, Y equals A plus BX, B is our slope and A is our y-intercept. The slope is a number that describes how steep our line is. So the bigger, more positive or more negative the number is, the steeper our line is. And the y-intercept is the coordinate of the point 0A, where the line crosses the y-axis. So here is a positive sloped line, and B is greater than 0. And again, the bigger B is, the steeper the line would be. If B equals 0 and we just have Y equals some number, that's a constant line. It's a horizontal line, and it's like fixed. It never changes because it doesn't depend on what X is going to do. And then here's a negatively sloped line. B is going to be negative, and the more negative it is, the steeper it would be going down. And you always want to read your graphs from left to right when you're talking about slope and what the graph is doing. So you go from 0 on the x-axis to the positive on the x-axis when you're reading your graphs. So a couple more examples. Svetlana tutors to make extra money for college. For each tutoring session, she charges a one-time fee of $25 plus $15 per hour of tutoring. So per plus one-time fee, those are words we want to be looking for when we're reading our examples or doing our problems. So we're going to write a linear equation that expresses the total amount of money she earns for each session in terms of the number of hours she tutors. So what are the independent and dependent variables? So the independent is X, the hours she tutors, and the dependent variable is Y, the total amount of money she earns per session. Our linear equation that expresses the total amount of money Svetlana earns per session is going to look like Y equals 25 plus 15X. So our fixed cost, one-time fee, 25, plus our rate, 15, times our independent variable X. So what is the y-intercept and what is the slope? And try to interpret them using complete sentences. So the y-intercept is that one-time cost, $25, and that's how much money she makes if she doesn't do any tutoring. That does not depend or change depending on how many hours she tutors. And the slope is 15, and that's how much she makes per hour. So every extra hour she tutors, her the total amount of money she makes goes up by $15. So Ethan repairs household appliances like dishwashers and refrigerators. And for each visit, he charges $25 plus 20 hours per hour of work. What does Ethan earn per visit? So independent and dependent variables. The independent variable is X, the number of hours he works, and the dependent variable is Y, the total amount of money he earns per visit. So what's our equation for Ethan? 25, that one-time charge, plus his rate, 20 times X. Y equals 25 plus 20X. And what's the y-intercept and what is the slope? And interpret them using complete sentences. So the y-intercept is the amount of money he makes even if he doesn't work any hours on a job, and is 25. And the slope of 20 is how much he makes per hour. So that is the end of the 12.1 video on linear equations.